This is our second video on addition and subtraction of fractions. And if you have missed the first video, which have simpler examples, I recommend that you watch that first. Also in this video, we'll need to apply some factorization. And if you forgot how to factorize, I recommend that you watch the review of factorization. In our first example, we have 1 over x squared plus x minus 12. And the second term is 1 over x squared minus 9. And what we want to do is find the LCD. But before we can find the LCD, we need to rewrite the terms in the denominator. And we can do this by using methods of factorization. In our first term, we have a trinomial in the denominator. And when we apply factorization to x squared plus x minus 12, we see that is x in the first bracket and x in the second bracket, and the factors of 12 would be 4 and 3, and the signs within the bracket would be plus 4 and minus 3 because we want to find the middle term of 1x. So therefore in the first term I'll have 1 over x plus 4 times x minus 3. And in our second term we can also factorize the denominator. So we have x squared minus 9, which is a difference of 2 squares, and that factorizes to x minus 3 times x plus 3. So therefore the second term would be 1 over x minus 3 times x plus 3. Now we can identify the lowest common denominator. The denominator in our first term is x plus 4 times x minus 3, and in the second term it's x minus 3 and x plus 3. So the lowest common denominator would be x plus 4 times x minus 3 times x plus 3. Notice we do not need to use x minus 3 twice because it already appears as a factor in our denominator. So therefore the LCD is x plus 4 times x minus 3 times x plus 3. And as in our previous video, we now have one single denominator. And in the first term, to create that denominator, I need to multiply the denominator with x plus 3. And I repeat that calculation in the numerator. So I'll have 1 times x plus 3. And in the second term, I need to multiply the denominator of x plus 4. And I repeat that calculation in the numerator, so I'll have 1 times x plus 4. Now I have the original expression as one single fraction, but it's not yet in its simplest form. So I would need to add like terms together in the numerator. And that'll be x plus x, which is 2x, plus 3 plus 4, which is 7. So I'll have 2x plus 7 over x plus 4 times x minus 3 times x plus 3. Now we have simplified the algebraic expression to a single fraction in its simplest form. In our second example, we have 3 terms and we want to simplify them to one fraction in its simplest form. So first let us see if we can factorize the denominator in the first term. And we find that we are not able to factorize the denominator in the first term. So it will not be a plus b times a plus b, because that will lead to a squared plus 2ab plus b squared. And it will also not be a minus b times a plus b. So we notice that we cannot factorize the denominator in the first term. In the second term, however, we can take out a highest common factor of a. So it will become a times a cubed minus b cubed. And in our third term, we can also take out a common factor of a. So it will be a times b minus a. So now I have started to factorize the denominators in order to find the lowest common denominator. And I notice in the second term I can still factorize using the difference of cubes. So my first term would remain the same. It'll be 1 over the 3 terms which I have. But in the second term, it will be minus 3ab over a times a minus b, a squared plus ab plus b squared. And if you forgot how to factorize a difference of cubes, please go watch our video on the review of factorization. And now I notice in my third term, I have similar looking brackets, but they are in the wrong order. So I can apply the sign change rule, which we have learned in the first video. So that will be plus 1 over a times a minus b. So if I change this negative to a positive, the terms in the bracket would switch around. Now from these denominators, I can identify the LCD. And the LCD would be a squared plus ab times b squared times a minus b. Note that I do not need to use these 3 terms twice, and I also do not need to repeat a times a minus b. So the LCD would simply be a times a minus b times a squared plus ab plus b squared, close the brackets. So in our first term, we need to multiply the denominator with a and a minus b, and we can repeat that calculation in the numerator. So it will be a times a minus b times 1. And the second term's denominator is already the LCD, so I do not need to manipulate the numerator. And in our third term, in the LCD, we need a squared plus ab plus b squared, and I'll multiply the numerator with those terms as well. So I'll have plus a squared plus ab plus b squared. Now I have the 3 terms as a single fraction, but it's not yet in its simplest form. So before we can add up like terms, I need to multiply a with a minus b. And that will lead to a squared minus ab. Now I can add up like terms in the numerator with one another. And that will simplify to 2a squared minus 3ab plus b squared over our LCD. And before I leave my answer like this, let me first check if I can factorize in the numerator again. So if I factorize in the numerator, I have a trinomial which leads to 2a minus b times a minus b. And if I compare that to the denominator, I see that the brackets of a minus b would cancel one another out. So therefore my final answer would be 2a minus b over a times a squared plus ab plus b squared.